Way to show up. I'm going to take it personal. Just went over the worksheet. The one that was due today? Yes. Yes. Right. Not exactly, but you should try and you should try and come in before school. That's, yeah. I know. Okay, so the next section is what's called the chain rule. I like doing the chain rule. Chain rule is a lot of fun. So you have functions that are kind of connected with we kind of call them chains, and that's kind of how you take its derivative. So we're used to figuring out derivatives like this. We don't know how to take the derivative of a composite function, but we are going to know how to do that now. Right? So right up till now, we know how to find the derivative of these four, but not yet those four. Right? Chain rule is relatively very easy to understand. So what you have is you have a function that's on the outside, and you have a function that's on the inside. All right? A lot of times you're going to hear me say, all right, you have f of the blob. Right? I'm going to call this inside function the blob. It's really no. Blob is a mathematical term. Huh? Yeah, the blob. All right. So how you're going to do it is it's almost like an onion. All right. You want to peel the layers and work your way in. All right. So you want to take the derivative of your outside function first. You want to keep the inside part, and then you're going to multiply this entire thing by the derivative of now the inside part. All right. So again, you're peeling back a layer. So you peel the outside layer. That's your first derivative here. You leave the inside part. You peel back another layer, and you keep going on depending on how many functions you have built inside of each other. All right. So you work from your outside, working outside to in. The derivative of the blob. Right. Right. Now you also want to rewrite as much as you can. All right. So right now it's asking, okay, what's the derivative with respect to x of the square root of x squared minus 1? All right. So again, you want to rewrite as much as you can. So I know that it's asking me to find the derivative of x squared minus 1 to the 1/2, right? All right, so you have really two functions here. You have blob to the 1/2 is your first function, and then on the inside of that you have x squared minus 1. All right, so I want to start on the outside first and then work my way in. Okay, so I have dy over dx is equal to, now, when you take just the derivative of, say, x to the 1/2, what would that become? Right, but in this case, x is x squared minus 1. So you have 1/2 x squared minus 1 to the negative 1/2. Okay. And now what I'm going to do is I'm going to multiply it now by the derivative of the inside, which is 2x. So again, you work on your outside, you work outside in. So imagine this is almost like x to the 1/2. So you're just taking the derivative of x to the 1/2 first, right? That's how you get this part here, right? And then you work your way in. So this is my next inside function. So the derivative of x squared minus 1 turns into 2x. Yeah. Yeah. term in front of the parentheses. Here? No. You have to treat this entire thing here as like a single term right now. So you bring the 1/2 down, right? You keep this the same. You subtract 1 from your exponent, and then you multiply it by the derivative of now the inside part, right? And then if this had, something inside of that, you would take the derivative of that. Like you just keep working your way in until you've taken the derivative of everything. So now you just have to clean it up. So I know that I have 1/2 times 2, which is just going to give me 1. And then this negative 1/2 is going to force this to go into the denominator. So that's going to leave me with x over the square root of x squared minus 1. So I see that I have a constant here, 1/2 and 2. So 1/2 and 2 is just 1, right? And then this negative 1/2 is making me turn this into the denominator, and then the x just goes on top. No, you can. Why not? Distribute what?
Like the 1/2, the x squared, and the negative 1.
Because it's an exponent, not a coefficient. This here?
No, like down
Here.
the 1/2.
So really you have 1/2 times x squared minus 1 to the negative 1/2 times 2x. You're just cleaning all that up. Like these are all links together. Like this is connected to this, which is connected to that. And then you're just cleaning it up to make it. No, you can leave it like that. No? Yeah. Yep. All right, so you have the derivative of sine of 5x. We know how to do sine of x, but we don't know how to do 5x. So you have two functions here. You have sine of x, and then the other function would be 5x. All right? So you have one built inside the other. Okay, so dy over dx, right? The derivative of the outside part would be cosine. Yeah, so it's like the first thing that you see when you walk up to the problem. So this would be sine. Yeah. Walking up to the problem. So derivative of, right, sine turns into cosine. You keep the inside function the same. And then you multiply that by the derivative of the inside function, which would be 5. So your final answer would be 5 cosine of 5x. That is your answer. How do you get 25x? No. The 5 is multiplying the cosine part, not the 5x part.
Isn't it because cosine like 5x is like basically 5, right?
Well, cosine's the outside part, so.
I mean like the cosine 5x we have there times 5, like that's its own thing, right? You can't like separate it.
Right.
Right?
Yeah.
So technically you're just taking the derivative of the outside function and you multiply by the inside function and the derivative of the inside.
Yep. All right, so you got 3x minus 2 to the 5th. Now, again, you could if you really wanted to, you can multiply out 3x minus 2 times 3x minus 2, but that would take forever. So your first function here, you would have like an x to the, you have a blob to the fifth, and then the inside function would be 3x minus 2. All right. So I have dy over dx, right? Blob to the fifth would be what? 5 blob to the fourth, good. Times now derivative of the blob, which is 3. So you have 15 3x minus 2 to the fourth. That would be it. Yes? Not. Anything you learn in school is you'll never do ever again. So. I don't know. What do you want to do next year? And do what? Besides that. Okay. What kind of teaching? Oh, really? Because you're right. Math teachers never do this. Huh? Yeah, but you like the math. If you're gonna be a math teacher, the math that you take in college, like this is like first week stuff. I took like Calc 5. No, that's for YouTube. That's not a class. All right, let's get one more. So I have x, right? That's one function, and then I have tan x squared, and then I have built inside of that is x squared. All right. So the derivative of x is just 1 minus, what's the derivative of tangent? Secant squared x squared times the derivative of x squared, which is 2x. So you have 1 minus 2x secant squared of x squared. All right, see you guys tomorrow. You too.